Hello everyone and welcome back to Just Finish Coding. I'm Sriram and this video is part 3 of our Tic Tac Toe AI series which we're making on Python. Now in case you've not watched parts 1 and 2, I will leave a card for you right here. So in those two parts we did quite a bit of coding where we basically had the board show up in the screen. We could enter in a move, but that was pretty much it. So in this video what we'll do is we'll be upping the computer's response to this move, and by the end of this video you'll have an actual response, although not very great one, to the player's move. Now I do want to apologize before we go on for the delay in this video. I'm almost 2 weeks late and I have not been keeping up my upload schedule with regard to the Python videos. This was because I was focused on my Scratch Geometry Dash videos, which I was releasing around the same time. And from now on, the videos will be out on time and I will release one video a week. So with that out of the way, let's start. The first thing I'm going to do is I'm going to go right, not to the bottom, but a little above the bottom. And I'm going to declare two new variables. So the first one is called move, and I'll set this move to be a boolean true. The second one is going to be called comp move, and I will set comp move initially to be 5. It just has to be some integer. You can even set it to 1 or 2, it really doesn't matter. Now move is basically going to check whether the computer is already chosen to make a move or not. And comp move is basically the final move of the computer. So for example, if this is the board, I think I told this in the first video, this was square 1, square 2, square 3, 4, 5, 6 and 7, 8, 9. So let's just say the comp move was 5, then it means that the computer is making the center square as its move. So that's pretty simple to understand. And now we also need to have some idea of the algorithm. So in this video, we'll only be doing a part of the algorithm, but the entire algorithm is going to go as follows. So first, we check if the computer can directly win the game. Then if the computer cannot win the game, then we check if the player is about to win and we stop the player from winning. In case the player isn't winning either, then we check if we are in one of these danger positions where we do not want to follow the rest of the algorithm. Now in case we're not in any of those danger positions, what we then do is occupy the center. If the center is already occupied, then we occupy one of the corners, and if all the corners are occupied, we basically occupy the edge. That's the whole algorithm. We'll just be doing the center, corner and edge today. Alright, so now that we have that out of the way, let's now code first the check center. So I'll do this above the update. So let me just have a couple of spaces there. And I will say def, oops, that was unintended. So I will say def check center because this is the first one. All right, so center, and I will just leave an open parenthesis. So nothing we're going to enter in there. So within this check center, we will basically use those two variables. So it's important we declare the global keyword for the both of them. So we can say global comp move comma move, and this is very straightforward. I mean, we just check if board 5 is vacant. So if board 5 is equal to this space here is empty string, then basically what we'll do is we will set comp move to be equal to 5, and we will also set move to be equals to false. Okay, so set move to false. I'm not entirely sure why this okay, yeah, it's gone. So I was initially curious as to why those things were highlighted in yellow, but as it turned out, it was just a temporary bug. Now before we move on, I'm going to make a little small change. So what I'll do is I will change this to just an empty string, and I will also do this for everywhere where we used a space instead. So that's in your square in two places. So you can also remove it from the clicked function, from the clicked method. And you can also scroll down to where you had board for I in range 10, and you can remove the space. Now I had just this, empty string coded in the original game which I made, and I don't really want to make a mistake with the spacing, so it's just important we correct this right away. So that's pretty much it. Next we can go to the other functions. So now the other functions are going to be pretty similar. So this one is going to be def check corner. Okay, so check corner. Let's do this next. We'll do check edge last. So once again here we need global comp move, and we also need move, right? Here it's a little bit more complicated because we have multiple squares that we need to check. So first of all, let us use a for loop for that. Now we can say for I is going to be a local variable now, in range as follows. So here's how we really need to think about this. The corners are squares 1, 3, 7 and 9. So we need to basically jump across them and see if any of those squares are vacant. So to do that, let's start off with 1 because that's going to be the start of the range. And the last one is going to be something above 9. It could be 10, it could be 11. I'm going to go ahead with 11 because we're going to step up by 2. Now, usually we just use two of these, we just enter in two values into this range function, but we can also enter in a third value, and that value is going to refer to the step. So in this case, our step is going to be 2. So we're basically going to jump from 1 to 3, from 3 to 5, from 5 to 7, and so on. Now there's a small difference you have to realize here, because we're going to use the check center algorithm first, and as a result, we do not want to have the fifth element being checked here. We'd want to avoid that completely. Now since it's just one element, we can just avoid that using a not. So you can say if board, not actually board, you can just say if I is not equal to 5. So in case I is equal to 5, it's just going to skip all the code. Now within this, we simply check once again this same thing. Instead of I though, instead of board 5 though, we will be using board I, okay? We're going to use this variable in range, and within each of these if then, it's fairly simple. We set comp move to be I, and we set move to be, I'm making the same mistake again. Yep, there we go. So we set move to be false now. Pretty much the same thing. But remember here we are in a for loop. So we want to get out of this for loop as soon as we make a move. To do that, all you have to do is just say break, and this will break out of the for loop which you are in. I'm going to copy this entire code now, and I'm going to paste this right after this because the code is going to be really similar. In this case, we're going to code check edge as the function name. Within the code, you can change this to be 2, and you can change this to be 10 because we're just going to check 2, 4, 6 and 8. So all of this is going to be the same. We can actually just remove this completely, and we can detab this entire thing. So to do this, I think you can select all. I believe it is in edit. I'm not sure where it is. Alright, so I'm just going to do it manually. I'm sure it's in one of those things. So de-indent is what we're looking for. So let's remove each one of those spaces. There we go. That's going to be pretty much it. So we just check if the square is vacant, and if it is, we make the move and break. So that's pretty much going to that's all we need for this whole function, and that's going to be all the functions we'll be coding today. What we can do now is define basically the computer move, and to do this I'm going to do it above the function. So let me have some spaces, and let me call this def comp move. Now keep in mind that I'm using a capital C here to avoid naming it with the comp move variable, and this is very important. If you don't do this, you'll start to get some weird bugs. So def comp move here, once again we'll be using global move, and we don't really need to use the other variable, which is comp move, because that's going to be limited to each of those functions. So we can just use global move here, and that's going to be pretty much it. So let's set move to be true initially, because at the beginning we haven't really made a move, so move is true. Okay, so we still have to make a move. That's what it's used to intend. We first of all check if move is true each and every time, and if it is, let's just do the part of the algorithm now. We can check center first. If move is still true, oops, that was unintended. So if move is still true, then we check corner. Okay. And finally, if move is still true, then we check edge. Now we don't really have to get into what happens, we don't really have to go into what happens if move, we've filled up the board completely, because that's going to be in the future videos where we have where we have the end screens and so on. We just need to make sure that the computer does make a real move. So that's going to be pretty much it. Now you can scroll down, and after this you need to actually make the move. You need to call and by making the move, I'm saying we have a move here to make, but we need to update it on the board. So to do that, we need to check first of all if not move. So in case move is true, it means we haven't made the move yet, and as a result we'd want to go to the end screen because it's a stalemate. But if we have made the move, then move is going to be set to false, and if not true, if not move is going to be set to true, and we'll enter this. So I'll be going through the entire squares list. So I'll say for square in squares. Okay, that's how I'll do it. And for each one of those squares, I will check if square dot number, which in case you remember, we defined it up here. We set it to be so we set it to be square dot number to be whatever we entered it in. And that was basically, 1, 2, 3, basically based on where the square was. So if square dot number is equal to comp move, then that's the square where we want to basically change into the O symbol. So all we have to do here is say square dot clicked, and we just enter in square dot x comma square dot y. Remember we did the same thing here. We did this s dot clicked mx and y. We're doing the exact same thing. I'm going to remove all the spaces which were unintended. I think the code is pretty well indented now, and we finally need to make one change before we can see our output, and that is within the clicked, because till now we have the computer function, but that doesn't do anything. So to make sure it does something, we can just go to this if self.content is vacant, and if the turn is x and the player has made a move, we set the turn to O, and then we simply call in the comp move function. That's pretty much it. If you just have this in place and then you run your code, you should have no errors. So I'm going to try to make a move, and you can see that the computer plays. Now it was actually playing quite smart now, but if you actually look at it and try hard, it makes some very stupid moves. So for example, it falls into a simple three-way thing. So let me just do this, and you can see that we can simply get a 3. But that's not the point. The point is that we have a computer which is making some legitimate moves, and in the next video we'll make this AI smarter with the remaining parts of the algorithm. If you've enjoyed this video, please make sure you leave a like, and also don't forget to subscribe and turn on the notification bell. Thank you so much for watching, and I'll see you in the next video.